Hi everyone. Welcome to our first day of our what's it called? Okay, hack hour. All right, and so for our first day, which is day zero, all right, we actually going to be looking at a challenge called the pivot index. All right, so this is not the challenge. This is to just me trying to explain to you what the challenge is going to be like, and then I'm going to drop the challenge in the okay in the DSA um, channel. That is the data structure and algorithm channel. All right, so okay, let's break it down. So, like, what exactly is the pivot index, right? So, for this particular index, I mean, the goal is that we want to be able to, okay, find, like an index where the sum of numbers, all right, maybe in an array, all right, to its left is equal to the sum of numbers to its right. Now, say it this way. A real world example, would be like, okay, something like, okay, an equilibrium. Do you get an equilibrium? So, you put your hand in the middle, trying to find the point of balance, all right, between the two edge of that particular object. Exactly. That is the picture. All right. So we're going to be walking through exactly how the pivot index works. All right. And based off this explanation, all right, you will be solving the challenge. Okay, so now let's break it down, right? So the pivot index problem using the example, right? So we have an input, and in this input we have an array of norms, all right? And we have an array of norms that has, that holds the items or the values 1, 7, 3, 6, 5, and 6. All right, so now the goal of this particular challenge, right, is to be able to find an index where the sum of numbers to its left equals the sum of numbers to its right. Now, note the the bold or the highlighted text. All right, so find an index where the sum of numbers to the left of the array is actually equal to the sum of numbers to the right of the array. Good. So let's go through this step by step. So the first step is actually to do this, all right, is to first calculate the total sum of the array. Now, calculating the total sum of the array would simply means that, okay, summing the entire numbers or the entire values of the array, which is 1 plus 7 plus 3 plus 6 plus 5 plus 6. All right, and then we have a total of 28. Okay, so we have a total of 28. Good. Now, what is the second step? Now, the second step is to actually initialize the left sum. All right. So, and the left sum, all right, always starts at 0. It always starts at 0. And the reason for this is because we are assuming that there are no elements yet at the left index of 0. We're assuming, all right? So always starts with 0. Good. It's very important to note that. Now, let's go through to step 3. All right. So in this step 2, we have a table that's, explain all of the process, the iteration, the workflow. We're going to look at that. So, um, step 3 is to loop through each of the index, okay? And so for each index, which is the I, now we're going to calculate the right sum, all right, equal to the total sum minus the left sum, then minus the current value, all right? The current value of the index, all right? The current value of the index in that particular, okay, at a particular iteration, all right? So please note this, all right? This is like a formula, all right? This is like a formula that would actually help you. So right now, we're going to be checking if this left sum, all right, is equal to the right sum. Good. So, okay, please don't forget, all right, we've already done a total of the entire values of the array, which is 28, and we save that in the total sum variable. Good. So now let's go through the iteration details. So in this table we have, in this table to the left, that is this, all right, we have our index values, all right, our index values, which is 0, 1, 2, 3, 4, all right, and then next to it is we have the current value at the index positions. All right, so it means at index 0 we have a value of 1, at index 1 we have a value of 7, at index 2 we have a value of 3, and so forth and so on. Okay, and so forth and so forth. So exactly, so now at the first iteration, right, the first iteration, so I said at the beginning that please, we always start at 0. The initialization always starts at 0, and you should note that. Good. So what we have here is at the index position we have 0. Then at the current so the current value of the index position at 0 is 1. Let's take a look at it here. You see it is 1. Good. So okay, let me just drop this so that we can be seeing the total sum and the table at the same time. Good. So then what do we have at the left sum? The left sum, like I told you, is always 0. Look at it here. All right, the initialization, the first initialization, we assume it is 0. Good. So now this is the right sum calculation, right, based off this formula, based off of this formula. Okay, so that's what is happening here. So we're having 28 minus so 28, which is the total sum, all right, minus 0, which is the left sum. Always start at 0. Always start at 0. Then minus what? Minus the current value of the index. All right, so which is 1. All right, which is 1 at this index 0, which is 1. So this particular one here. So when we have 28 minus 0 minus 1, we have the value 27. All right, good. So now is 0. So right now we are checking if the left sum is equal to the right sum, and the left sum, like I said, the value is 0. Always start at 0. So is 0 equal to 27? Is 0 equal to 27? Now, of course, that is wrong. All right, 0 is not equal 27, so that is wrong. So then our action is okay, so the left sum, all right, is now so this left sum plus equal 1 just simply means that okay, left sum, I mean, we are okay, reassigning the value of the variable, all right, and then incrementing by 1. Okay, reassigning the value of left sum and then incrementing by 1. So it means left sum equal to left sum, which is 0, all right, plus 1. This 1, which is this nums I, the current value of the current value at index 0, which is this 1. Okay, so now we have 1. All right, good. So then we go over the iteration again. So please remember, this is a for loop actually, because iteration is a for loop, right? So we go back again. So right now at index 1, we have the value of 7. All right, and then right now our left sum is 1. This is our left sum. This is the total of our left sum, which is now 1. Okay, so it means we moved from this 0, which is the left sum, all right, to 1. Good. So right now we're having at index position 1, we're having the value 7, all right, and then we are having our left sum. That's the value of our left sum to be 1. So it means 28 minus 1, all right, minus 7. So which means the total sum, this same formula, all right, this same formula. So we are calculating the right sum right now. So it means the total sum, which is 28, minus the value of the left sum, which is 1, all right, minus the value of the current index. So we are at index 1 and the current value is 7, which is nums I, all right, in the second iteration. Good. So now we have 20. All right, so right now we're saying now the value of the left sum we have is 1. So is 1 equal to 20? Of course not, it is not. All right, so that is wrong, it is not. So it means that okay, our left sum, all right, is now, so here we're actually doing a reassignment again of the left sum variable. So it means the current value, I mean, so it means left sum equal to the current value of left sum, which is 1 plus 7, and now we have 8. Do you get? Right now we have 8. Good. So then moving forward, the next iteration, right? So we're having the what's it called at the next iteration we are at index position 2, all right, and then our current value for position 2 is 3, all right, and then right now we have a total, we have the value of 8 for our left sum, which we got from this particular point, all right, exactly. So going through the formula again, right sum calculation. Okay, so our total sum is 28, all right, minus the left sum, which is 8, then now minus the current value in our index position, which is 3, all right. So at index position 2 we have the value of 3, all right, good. So 28 minus 8 minus 3, we have 17, all right, we have 17. So now we are checking if the left sum, which has the value of 8, all right, is equal to 17. Of course it is not equal to 17, all right. So then what do? We reassign the value of left sum and then increment it, or sum it, all right, by the previous value of our left sum, so which is left sum equal to left sum, which used to be 8 plus 3 now. Do you get? Plus 3 now. So this 3 is the what's it called, this thing is the current value, all right, from the array, exactly. So right now we are having a total of 11. Okay, I hope you're getting me. Good. So moving forward, all right, so right now we are at index position 3, which is right now we are going back again to reiterate, all right, to reiterate through the for loop. All right, so we are at position we are at index position 3, and then our value in the array is 6. Let's go back and take a look at it. You see, so 0, 1, 2, and 3. Good. Let's come down to our table. All right, so value is 6, and then our left sum is now 11, which we got from here, right? This calculation right here, good. So then let's go through our right sum calculation again based off this formula. We have total sum, which is 28, minus left sum, the value of left sum, which is now 11, all right, then minus the current value of our index, which is 6, all right, so we have it here. So now 28 minus 11 minus 6, we have 11. Good, we have 11. So now, does 11 equal to 11? Of course 11 is equal to 11, so we return 3 as our pivot found. Do you get? So now it's called pivot index. So you may ask, why doesn't it return 6? Because like, you know, what's it called, because it is this 6, because it is at this value of 6, all right, that was able to get 11. No, we do not return the value of the index. What we return is actually the position of the index of the value. And so at index 3, at position index 3, our value is 6. All right, so it means this is actually what we're looking for. So the pivot index is what we're looking for, not the value. Good. So that is why we returned 3. So since we've returned 3, then it tries to go over the loop again. It tries to reiterate over the array, all right, maybe the fourth index, all right, which has a value of 5, and then right now it's trying to, like, okay, so let's do left sum. So left sum, that is 11 plus 6, which is 17. So here the loop exits early because the pivot is already found, so this doesn't actually execute. Okay, so why does this work? This is the math trick, all right, this is the formula, this is the reason why our pivot index calculation works. So this is what, like, you know, the algorithm or the code will be reiterating this thing